Okay, so let's have a look at this AQA Physics A-level question. It's a momentum question in the mechanics topic. Right. So, state in words the relationship between force acting on a body and the momentum of the body. Alright, so I've actually just pre-written this one. Basically, I'll do it as an equation, right? But they don't want you to write it as an equation. In fact, the mark scheme specifically says don't give the mark for just symbols. But since Newton's second law, F equals ma, can also be written as m delta v over t, right? Momentum can be thought of as change in momentum divided by time. Sorry, force can be thought of as change in momentum divided by time. Or momentum, given the symbol rho, could also be thought of as, so multiply both sides by t, could also be thought of as force times time. So that's what I've just said in words here. Okay, next step is show that the velocity of the sand as it lands on the container is 5.6 meters per second. Right, so again, hopefully you've read the question, because you'd have paused the video and read the question. A container rests on a top hand balance, blah 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 blah. Sand falls at a constant rate of 0.3 kilograms per second into the container, and it falls an average vertical height of 1.6 meters. So, two ways of approaching this. Essentially, we're just thinking about a drop. It falls 1.6 meters. Okay, and you've got to find the velocity at the bottom. So you can either think about it in terms of energy, in which case mass times gravity times height is being converted into kinetic energy, which is half mv squared. Mass hasn't changed. Multiply both sides by 2 gh equals v squared. Square root both sides. Root and the square cancel. So v is equal to root 2gh. Or you could go at it from the Suvat equations. And the Suvat equation that you would use in this case would be v squared equals u squared plus 2as. And if you wrote out your Suvat, S-U-V-A-T, S is 1.6. U, well, it starts from here at rest, so that's 0 meters per second. V is what you're trying to find. A is 9.81. T, we don't know, but we don't need. So, again, U gets cancelled. Sorry, that should say 2as. U gets cancelled, and you root both sides. So, subbing the numbers in, root 2 times 9.81 times the distance of 1.6 meters, and when calculated, does give you 5.6 meters per second. So, confirming what the question has told us to confirm. Right, next part of the question. Calculate the magnitude of the momentum of the sand as it lands in the container each second. So you can see the examiner is trying to lead us into thinking about something here. They've got us to define force in terms of momentum, mv over t. Now they're telling us about momentum change per second, which essentially is force, which will help us answer the next bit of the question. So let's do this bit. Okay, so I want momentum. So momentum is mass times velocity. The mass landing per second from the previous part of the question is 0.3 kilograms. So it's 0.300 kilograms times the velocity, which is 5.6. Okay, and calculating that gets me 1.68. And the unit has been given to us. Note that the unit could also have been kilogram meters per second or Newton seconds, right? They both mean the same thing. Right. Next step. The mass of the container is 0.650 kilograms. Show that the reading on the balance after 10 seconds of sand landing continuously on the container will be 3.82 kilograms. You may assume that the sand comes to rest without rebounding. Right, so immediately, right, think about the container, the scale that is reading this, right? So here's the scale and here's the reading. You put the scale on and it's going to read 0.650, okay? So you've definitely got the 0.650 because, not you put the scale on, so you switch the scale on and you put the pan on. right? The pan weighs 0.650, right? You've got 10 seconds worth of sand, and you're getting 0.3 kilograms a second. So 10 times 0.3, right, is going to be 3 kilograms. So we're adding to that the 3 kilograms. So this gets us 3.650 kg. So it says show that it's 3.82 kilograms. So the examiner's actually being very kind to us again. They're really building us up to try and get our head around what's going on. They're helping us out. Where's the missing mass? Ah, right, well, it does tell us that the sand comes to rest without rebounding, which means that the sand is experiencing a change in momentum per second of 1.68 Newton seconds, or kilogram meters per second, right? So the sand is coming to rest. So imagine any situation where you have to bring something to rest. If you have to slow anything down, it's going to require you to apply a force to it. If you put your hand out and catch something landing in your hand, a heavy object, right, you have to apply more force to slow the thing down and bring it to rest as you catch it, which is kind of why cricketers, you know, cup and draw their hands down as they catch a ball coming at them fast, in order to decelerate the ball over a longer period of time, reducing the force on their hands and not hurting themselves. So that's really this extra force and where it's coming from. So this isn't enough to answer the question, right? We've got to have the mass of the container, 0.650, plus the mass of sand that lands in the 10 seconds, right? That's 10, by the way. Plus, well, how do we work out the mass? The equivalent mass of this force. Weight equals mass times gravity. So mass would be weight divided by gravity. And the weight value, because this is Newton's seconds, and this is in 1 second, this is the equivalent of the force, right? 1.68 newtons divided by 9.81. Okay, 1.68 divided by 9.81 comes out as 0.017 kg. That's what the scale would read, right? Just because of the sand landing on it. Okay, and when you sum all this together, hey presto, we get 3.82 kg. Okay, so again, 3 marks for that, and you have to show your working if you want to be able to get the marks for it, because obviously they've given you the answer. You've got to show the examiner that you understand where the answer came from. Alright, next step. It takes 20 seconds for the sand to fall into the container. On the axis below, sketch a graph to show the reading, how the reading of the balance will change over a 30-second period. No further calculations are required, and values need not be shown on the vertical axis of the graph. That's nice. Okay. You don't need to show the values, but just for the sake of clarity, I will put a few things in here. So the balance starts out with the pan on it. So the balance starts out at 0.65, right? There's a reading. At 5 seconds, the sand starts to land. Okay, so just put a dotted line in here just to help me sort of work things out. Now, the real trick to this question is you're expecting the line to go up like this, right? At a rate that of 0.3 kilograms per second, right? But, right, you've got to take into account this extra value here, okay? So actually, the sand starts landing, the scale jumps up immediately as it's been hit by this moving sand, and then starts to increase, right? And then after the sand stops landing, let me just get the rough line where that is. After the sand stops landing, it jumps back down again, right? So you've got this extra little bit. I'm just going to try to maybe highlight what I'm talking about here. So in yellow, jumps up, jumps back down. Okay, maybe not as clear as I wanted it to be. Let's try a different colour. Okay, now just to confirm we fully understand this, because it doesn't rebound, its change in momentum is this. If it did rebound, right, if it bounced back off at the same velocity, so imagine instead of dropping sand onto the pan, we were dropping bouncy balls, they'd hit and bounce off. Okay, they wouldn't come off at the same velocity, but let's just pretend they do. The change in momentum would be twice this. So that would make this twice as high, right? Because this force, this extra reading here that we're getting, here would be twice as big. Okay, so I hope you found this helpful. If you have any comments or questions, please make them on the YouTube channel. Thanks for watching.